Good morning, students. Today we will discuss about the most important topic, silicon control rectifier of subject power electronics. So now, what is power electronics? Power electronics subjects deals with control and conversion of power at high voltage and rated frequency. In power electronics, most important switch is silicon control rectifier. There are many different switches are there. SCR, diode, triode, IGBT, all these LASCR, all these are power electronic switches, but mostly widely used device is silicon control rectifier. Today, what I am going to discuss about the ACR, what outlines are introduction of ACR, construction of ACR, different mode of operation of ACR, what are the different applications of ACR, and advantages of ACR and disadvantages of ACR. So, what is ACR? ACR stands for Silicon Control Rectifier. See here, why term ACR is used? Silicon Control Rectifier, ACR, silicon material is used for its construction and its action is control rectification. See here, it is invented in the year 1956 by Bell Telephone Laboratory in USA. It is the most important member of ACR family and it can used as a converter. It can convert AC to DC, DC to DC, DC to AC. Most converters used silicon control rectifier. Now I am going to discuss about the construction of ACR. So ACR is a three-terminal device. See here, different terminals are there: anode, cathode, and gate. It is a four-layer device. Four-layer device: P layer, N layer, and P layer and N layer. This device has three junctions: J1, junction 1, J2, junction 2, and J3, junction 3. The symbol of ACR is shown here. ACR symbols: A stands for anode, K stands for cathode, G stands for gate. What are the different states of ACR? That is, it can operate in on state and off state. So it is act as a switch. Next, what is the switching frequency? It operates within 1 kilohertz to 20 kilohertz. So ACR have highest voltage handling capacity. And what is the main applications of ACR? So ACR can be used for switching, operation, and amplification. So next, construction of ACR. It is a PN device. It consists of four layers. Outer P layer, see here, outer P layer is called anode, and outer N layer, see here, outer N layer is called cathode, and inner P layer, see the inner P layer is the gate. So next, what are the three junctions? These are the three junctions are there, J1 and J2, as I explained earlier. So how ACR works? See, generally ACR is operated when anode is connected to positive side of the supply, cathode is connected to negative side of the supply. So, and load is connected in series with the anode. So, working of ACR can be represented by when gate is open circuited and gate is connected positive supply with respect to cathode. See here, in this slide I am going to explain you operation of the ACR when gate is open circuited. See here, anode outer P terminal is connected to positive side of the supply. Outer N, that is cathode, is connected to negative side of the supply. load R1 is connected in series with the anode, and here no voltage is applied between gate and cathode, means gate circuit is open circuited. So SCR is said to be forward biased because anode is connected to positive side of the supply, cathode is connected to negative side of the supply. So in this period SCR will J1 will act as forward biased, J2 act as reverse biased, and J3 will be reverse biased. So no current will flow through the SCR. So SCR will remain in off state. So how to turn on SCR? If we apply positive supply voltage when anode is connected to positive side of the supply, negative side is connected to cathode, so SCR will turn on. See here, when gate is positive with respect to cathode, the SCR is forward biased. So when SCR is forward biased, J1 and J3 are forward biased and J3 junction is reverse biased condition. So electrons start moving from N type to from junction J1 to J3. Similarly, holes are moving from P type material to an N type material. So after some time the SCR will turn on. So what are the different modes of operation of the SCR? So there are three modes of operation of the SCR. First one is forward blocking mode, means it remains in off state. Next one is forward conduction mode, it is in on state, and reverse blocking mode, so it is in off state. First we will discuss about the forward blocking mode, next we will discuss forward conduction mode, and we will discuss forward blocking mode. See here. So what is forward blocking mode? In this mode of operation, SCR blocks the current, no current is flowing through the SCR. So it is remain in off state. In forward conduction mode, in this mode SCR is turned on and it is in on state. And reverse blocking mode, in this mode of operation, totally it is in off state. See here. See here, forward blocking mode. So when in forward blocking mode, anode is connected to positive side of supply, cathode is connected to negative side of the supply, and gate voltage is open circuited, no supply voltage between gate. See here, during that period SR is in off state, but we gradually increase the voltage, SR will turn on. See here, this shows this is the graph between voltage and current, and we are applying the positive voltage will increase gradually. So this voltage is forward blocking state. After this no current will flow. See here, next one is forward conduction mode. If you increase the voltage gradually, then reverse bias junction barrier J2 vanishes and current will flow through the SCR. So see here, when this shows forward conduction mode. See here, forward conduction mode is shown here. So next is reverse blocking mode. So when reverse blocking state operates, when cathode is connected to positive side of the supply and anode is connected to negative side of the supply. So junction J1 is reverse biased, junction J3 is reverse biased, and junction J2 is forward biased condition. So both the junction will oppose the flow of current. So this figure see here in the graph, this is the reverse blocking mode. No current will flow through the SCR, and if you increase the voltage gradually at certain state, so completely J1 barrier and J3 barrier vanishes and SCR will getting damaged. So operation of the SCR during reverse state is completely forbidden. Next we will discuss about most important definitions are latching current and holding current. See here, what is latching current? It is related to current regarding the turn on process. So it is the minimum amount of current required to maintain the SCR in on state. See here, IL, this shows the latching current. It is the minimum amount of current required to keep the SCR in on state. Next is holding current. Holding current is related to turn off process, and here see holding current is related to turn off process of the SCR. So after the SCR has been switched on state, certain minimum value of anode current is required to maintain the SCR in on state. So if this current reduces from this holding current, the SCR will turn off. So there are different methods of triggering of SCR. First one is forward voltage triggering, temperature triggering, light triggering, DVIT triggering, and gate triggering. So what are the different types of gate triggering? That is AC gate triggering, DC gate triggering, and pulse gate triggering. First I will discuss about the forward voltage triggering. See here. Forward voltage triggering means anode is connected to positive side of the voltage, cathode is connected to negative side of the voltage. During that period, we are going to increase in voltage. At certain voltage, SCR will turn on. So this method of turn on of SCR is strictly prohibited because we need around 5 to 600 voltage to turn on the SCR. So it is completely avoided. Next one is temperature triggering. When SCR is forward bias condition, junction J1 is forward biased, junction J3 is forward biased, and junction J2 is reverse biased. If you apply some temperature to the junction J2 after certain time, so J2 will be in conducting state. So if you put some temperature in junction J2, SCR will start conducting. This method of conduct is called temperature triggering, but it is not practically used. Next one is dVdt triggering. So dVdt triggering means when SCR is forward bias condition and it is connected to positive side of the supply and cathode is connected to negative side of the supply. So there are 4 layers Pn and Pn. Junction J2 act as a capacitor. If you apply voltage suddenly, so it will create large current and it will start conducting. So this is called dVdt triggering because rate of change of voltage at fraction of a second will increase the current in large amount. So SCR will start turn on. Next method of triggering is light triggering. So when SCR is forward bias condition, anode is connected to positive side of the supply, cathode is connected to negative side of the supply. So we can apply light to junction J2. So there is a terminal here, it is called niche. We put light. So if you put light after certain period, immediately junction J2 barrier will start conducting and SCR will turn on. So this method is called light triggering, and this method is used in light activated silicon control rectifier. It is most widely used in application. So next one is gate triggering. We have explained we can apply DC supply to the gate, we can apply AC supply to the gate, or we can apply pulse to the gate. See here, only 5 to 6 volt is required across gate for DC gate triggering. See here, what is the advantage of this method? It is very simple and reliable and efficient way to turn on the ACR. When it is applied, when ACR is forward bias condition, gate cathode is connected to small voltage around 9 to 10 volt. So by applying this small voltage, we can turn on the ACR. So this method is widely used for gate triggering ACR. Next one is AC gate triggering. Similarly, when ACR is in forward bias condition, we can apply AC supply to the gate. So during positive half cycle of the AC supply, gate is positive with respect to cathode and gate voltage gradually increases and ACR will turn on at certain voltage. So this method is called AC gate triggering, but this method is not widely used. Next one is pulse gate triggering. So this DC gate triggering and AC gate triggering have certain losses. So we have to reduce the losses. So we apply the pulse triggering. So when ACR is forward bias condition, we just apply small pulses across gate and cathode so that it will turn on easily by reducing the losses. So next is, what are the different applications of ACR? See here, ACR is used in inverter, ACR is used in chopper, ACR is used in for power control, battery charger, UPS, all devices uses ACR. So what are the advantage of ACR? So ACR can control very high voltage and it operates in rated frequency. So it can handle very large voltage and current and power. Cost of ACR is very low. Next is, it is simple to control, small in size, light in weight, and it has reliable in action. Next one is, no mechanical parts are there, so there is no noise. So in power electronics, most of the applications in converters uses ACR because it is very light in weight, reliable in operation. It can handle very high voltage. So any device, switching device, have certain advantages and disadvantages. Similarly, here certain disadvantages are there. So it is a only unidirectional device. ACR can operate only one direction only. So it can used only for DC power only. And gate current cannot be negative. This is the most disadvantage of the ACR. So it cannot be operated in very high frequency. So in rated frequency it can be used. Next one is our conclusion. So ACR has two states. It has either on state or off state, means either conducting or non-conducting. So it can used as a switch. Next one is, advantage of ACR is by applying small gate voltage we can turn on the ACR easily. So it can control very high voltage and working between 50 Hz to 10 kHz, triggering voltage is very less. Thank you all.